So, extreme value theorem is going to deal with absolute maximum and minimum. So, an absolute maximum or minimum is the highest or lowest point, lowest if you're talking about minimums, on the entire function for the given domain. So, if f of c is the absolute minimum of f on the interval I, then f of c is greater than, oh, I'm sorry, this is a minimum. Fix that. Is less than or equal to f of x for all x in the interval I put the or equal to there because you can have more than one absolute minimum point. You can only have one absolute minimum value. That's your lowest, the value is your y value, but that can occur at different x values there. So it can happen more than once. For example, if you have like a function that looks like this, it can have two absolute minimum value points there for that. So, if f of c is the absolute maximum of f on the interval I, then f of c is greater than or equal to f of x for all x in that interval. So absolute maximums and minimums are also sometimes called, what are they sometimes called? Global. Global maximums or global let's see. I don't think I meant for that to be global there. Global maximums or extrema. I like the term absolute much better, but occasionally they will use the term global maximums versus local maximums. Local maximum or minimum you may see more. Usually they say absolute maximum or minimum if they're talking about that, but you could see this term. And extrema just means maximums or minimums, so those are your highest or lowest points. So it's a way of asking for both maximums and minimums. Local. Local is going to be, we'll talk about this on the next slide, is your relative maximum or minimum. So a relative maximum or minimum is higher than the points around it, but it's not necessarily the highest point on the graph. If a point where the graph switches from increasing to decreasing or vice versa. So, for example, if you're like looking at a cubic function, then something like this, you would have a relative maximum or a local maximum, sometimes it's called, and a relative minimum. It is not the absolute highest point on the graph because this graph continues upward forever. And same over here, this graph continues downward forever. So these would be just relative maximum or minimums. Now, all absolute maximum or minimums within the interval anyway are also going to be relative because they're going to be a switching point for that, unless it's at the end points, which we'll talk about in a minute. So if there is any closed interval containing C on which f of c is a maximum or minimum, then f of c, oh no, I think that's supposed to be open. Hold on. I need to be looking at these filled in today. I'm not with it. That's open. If there is any open interval containing C on which f of c is a maximum or minimum, then f of c is also called a... I know. What was I even thinking to fill this in with? I knew it whenever I did this. In my new notes I've been doing for Math 3, what I do is I put the blank there, but then I make the text, I just change the color to white, and then I can go highlight it, and I know what I was supposed to put there. That's a trick I learned this summer that I should have thought of long before now, but obviously I didn't do that on these. I think it's just supposed to be relative right there, but or local. Maybe I meant to use local. Let's just use local. Local. Yeah.
We can't always be perfect.
We can't, no. So, we'll be alright. Okay, so this is just a Desmos graph to kind of like give you an example again. This point right here is a relative or a local maximum. It is not the highest point on the graph. But that last definition, what it's telling you is if there's any interval where you could like section that off. So for example, if I just went from -2 less than x less than 3 right here. So if I don't look at the whole graph, if I just look on an interval, then this is the absolute highest point, right? So if that is the case, if you could section it off to like, if I just look at this section, that's the highest point, then that is a relative maximum or minimum. And so you'd have a relative maximum here, a relative minimum. But of course, if you look at the whole graph, it is not an absolute because you have points that go higher and lower for that, I believe is what I meant to say. I think. All right. So this one gives you a graph. You're supposed to find all maximums and all minimums for this that may exist. So this should be, you know, pretty straightforward. I do want to emphasize here what the x value and the y value are for this. So it says for this graph, find all maximums and all minimums. You really only have one on this. What do you have? Okay, the point 3, -4 here is going to be a minimum. And is it relative or absolute? Absolute. Now, technically, it's also relative because it switches from decreasing to increasing. But because there are no points lower than it on the whole graph, it would be absolute. So you would have, so what you would say for this is the absolute minimum value so the minimum is your y coordinate. This is your y. This is your minimum. So the absolute minimum value is -4. We could say this minimum value occurs at x equals 3. So the minimum or maximum will occur at the x value, but the actual minimum value or the maximum value is your y coordinate. So your y coordinate is the maximum or the minimum. So it depends on how they ask. So like for this, it says find all maximums and minimums. This one, you could just answer it with the first sentence. The absolute minimum value is -4. Because it does not ask where it occurs. Now, I think you'd probably be okay if you gave the full point, 3, -4, but the y coordinate is the minimum or maximum value that they're really looking for there. So for this one, we're supposed to find all maximums and all minimums. And the graph is a little, you have to estimate just a little bit for that. So do we have any absolutes on this graph? We do not have any absolutes. We have a relative maximum and a relative minimum. So our relative maximum right here, we would say the relative maximum is, looks like 35, yeah. And I'm just going to put which occurs at. X equals -3. And we would say the relative minimum is 3, which occurs at one. Let's do x equals 1. So the actual maximum minimum value is your y coordinate. It occurs at the x coordinate. Unless they specifically ask for the x coordinate, you could get away with just giving the y on that. So that, like, second, I'll put this in parentheses too. That what I've got in parentheses there is sort of optional. You wouldn't necessarily have to write that given what is said here. Okay, now for this one's different because this one has endpoints, not just it has endpoints, not just your arrows on the end. Even though I'm having a little trouble, I'm trying to remember if I may have to consult the Facebook group later on this one. I'm feeling two of them I know very, very certainly about. I'm going to have to go consult the Facebook page later. I know I've seen it mentioned on there. All right, so let's talk about the ones I know for sure. This graph has an absolute maximum. What is the maximum? It'll be 12. It's right here. So this is actually a case where you don't have a relative. I don't think you have a relative. You don't switch from increasing to decreasing. You don't have a relative maximum, but you do have absolute because it is the highest point on the graph. So you would have an absolute max is 12, which occurs at x equals 7. You also have an absolute minimum. What is our absolute minimum? -4, which occurs at x equals 3. Those I'm certain about. Without a doubt, those are correct. What I can't remember is if 5 is a relative maximum. I don't think it is. But I'm not 100% sure. I think it is not. Because if we have like an open interval, there's no open interval we could use that would work for that. So, yes, so if this did go, like, let's say that went all the way up to 12, right there. That's a good question. Like, let's say it does that right there. Then, what we would say if that were the case is we would still say that our absolute maximum is 12 because that y-coordinate is your maximum or minimum value. So we would still say absolute maximum is 12, but we would say which occurs at x equals 7 and x equals negative 1. So it can happen at more than one point. Multiple points could. It's still only one maximum value because the y-coordinate is your maximum value, but it occurs at more than one point. That's a good question for that. All right, for right now, I'm going to say, though, right there, as it is, that that's neither one. But I'm going to go back and look up. I know I've read that on a conversation on the Facebook group, but I can't remember. I remember there was a conversation about whether or not the endpoints were relative maximum minimums, but I can't remember what the conclusion was on that. So I'm going to go with neither. I don't think it's either one right there, but that could be amended once I consult the experts. Okay, so this last question leads into what our focus is for today, and that is the extreme value theorem. So if you cut a graph off, so instead of looking at something that has arrows on the end, you have endpoints, right? You have to have an absolute maximum and an absolute minimum value. Because since the graph stops at some point, somewhere has to be the highest or the lowest point on that graph. Now, when you have arrows, that's not necessarily the case because things can go to positive infinity or negative infinity. And if a graph goes up to positive infinity, then there is no highest point because infinity just keeps on going. And theoretically, you never get there. So, so the extreme value theorem basically just says that if f is continuous on a closed interval from a to b, so closed interval from a to b, that's what's saying we cut the graph off. We're only looking at this section of the graph and we've got solid dots on the end. Then f has both a minimum and a maximum on that interval. Has to happen. And here I did not put absolute minimum or maximum. You may want to make a note of this. If you see maximum or minimum without the words absolute or relative, then that minimum or maximum is going to be absolute for that. So, minimum or maximum is going to be absolute in this wording. If it's asking for a relative maximum or minimum, which we will talk about more in the sections to come, today we're mostly going to focus on absolute. If it's asking for relative, it will always say relative, or it will ask like what kind of maximum or minimum you have there. Or it might use the word local. All right, so critical numbers. Critical numbers are points where the derivative of the function is equal to 0 or undefined. So, for example, if I look at this graph, anywhere that my derivative is equal to 0 or is undefined is going to be a place where I have what we call critical numbers. Okay, so if this is my graph, and I'm looking for where the derivative is 0. Who could give me a point where the derivative would be 0 in this case? Over here?
No, 4, 0. Or 0, 4.
0, 4, yes. Right there, you'd have a horizontal tangent line, right? So x equals 0 would be a critical number for this. Okay, where else would I have a horizontal tangent line where my derivative would equal 0? 2, right there at the point 2, 1. And critical numbers, I should have put maybe x points or x coordinates. So x equals 1 would also be a critical number. You've got one more here. almost negative 3, negative 2. Yeah. So x equals negative 3 would also be a critical number. And I don't think this would have any vertical tangents here for this. So vertical tangents are a little harder to spot. We'll look at some of those later. A lot of these we're going to be doing from the equations anyway. So finding critical numbers is going to be a big thing that we're going to look for, because as you can see on this graph, what happens at all of those points where our derivative equals 0? That's where we've got a change in direction, right? We've got maximums or minimums. Now, that doesn't have to always happen. The reason those aren't just called maximum or minimum points, and they're called critical numbers, is because you don't have to have maximum or minimums at those points, but you may. So, critical numbers that are going to be critical for us to know how to do. Perfect. So, if I want to know critical numbers, I must first find the derivative. So, for this first one right here, Liam, what would we get for that first derivative, for example, 4? Okay, and we want to know where this is 0 or undefined, but is that ever going to be undefined? Undefined is going to be something like zeros in the denominator, right? And we don't have a denominator here. So this can't be undefined, but it could be 0. So we're going to say 9x squared minus 4x equals 0. And we did something similar to this on the warm-up. How did I solve that? Pull out an x. 9x minus 4 equals 0. So we'll get x equals 0 and x equals 4/9. You guys okay with me shortcutting that there? All right, and these two right here are our critical numbers. So there is a good chance there's a maximum or minimum point at those, but not necessarily. Sometimes there's not. Okay. Questions on that? Now, all we're doing right now is critical numbers. We'll add something to this in a minute so that it'll fit in with the maximum minimum stuff. We're just practicing that right now. Example 5 is a little bit tougher because the derivative is a little harder to find. So if I take the derivative of this, what do I have to use? Quotient. So I will do f prime of x will be x squared plus 1 times 4 minus 4x times 2x all over x squared plus 1 squared. And so I will get 4x squared plus 4 minus 8x squared over x squared plus 1 squared. And if I combine my like terms there, I've got 4 minus 4x squared over x squared plus 1 squared. So here I have a derivative that does have a numerator and a denominator, right? So I want to know anything that would make this equal to 0 or that would make it undefined. So for this to equal 0, the numerator would have to be 0, right? We'd have 0 over some number. Numerator would have to be 0, denominator would not be 0. So we wouldn't want to get 0 over 0. It's not going to happen on this one, so it'll be fine. And it doesn't usually happen. For this to be undefined, the denominator would have to be 0. All right. So what I'm going to do at this point is I'm going to say 4 minus 4x squared equals 0. I'm also going to say x squared plus 1 squared equals 0. So I'm looking at both what would make the numerator 0, which would make the whole thing equal to 0, or would make the denominator 0, which would make the whole thing undefined. So if I solve this first one, I'll just have 4 equals 4x squared I will divide both sides by 4. Here, I will get 1 equals x squared. And I will square root both sides. What will I get for my values there? Plus or minus 1. Very good. Don't forget that plus or minus when you square root both sides. Okay. Over here, I would have to square root both sides. So x squared plus 1 would be plus or minus 0, but that's unnecessary whenever you have 0, so I'm just going to put 0. I would subtract 1. So x squared would equal negative 1. I will square root both sides. Ooh, what's that? That's an I, right? And I is not a real number. It doesn't show up on the graph. It's not going to be a maximum or minimum point, right? So this does not give you anything. There is nowhere that this is undefined. If you think about it, look at what you're doing to this number here. Whatever this number is, you are squaring it. What's going to happen to a number when you square it? It's going to be positive, right? So I have a positive number here. I'm going to add 1 to it. It's going to make it more positive, right? Now it's a positive number greater than 1. And then I'm going to square that. Positive. There is no chance that this can be anything but a positive number. So that means it also can never equal 0 for that. So it should make sense that we're not getting an answer for this. Now, if that was a minus 1, it would be possible for it to be 0, and we would get some answers there, and we would have more critical points. But here, we just have 2 critical points here. Which are our possible points for our maximum minimums. Questions there? All right, so extrema on a closed interval can only occur at the endpoints of the interval or the critical numbers. So in order for you to have a maximum or minimum point, it is either going to happen at the endpoints or at the critical numbers. It is not going to happen at any other points on the graph. So whenever we are asked to find absolute extrema, we need to first find the critical numbers, because the critical numbers are the places where we possibly have a maximum or minimum. So, for example, here we have f of x equals x to the third plus 3x squared. So we would take the first derivative. We get 6x squared plus 6x. And we want to know where that is 0 or undefined. Is this one ever going to be undefined? No, just 0 for this one. So we will say 6x squared plus 6x equals 0. So we could factor out an x or a 6x, whichever way you want to do it here. So 6x would be x plus 1 equals 0. And so we'll say 6x equals 0, which just gives us x equals 0, and x plus 1 equals 0, which gives us x equals negative 1. So those are my critical points. So what I have here is I've got a critical point at 0, a critical point at negative 1. I also have endpoints at negative 2 and 1. Does 0 and negative 1 both fall on that interval? Yes. So now if I got, like let's say I got negative 7 here, I would not use it because it doesn't fall between negative 2 and 1. I just throw it out for this problem. But these are all on the interval. So what's going to happen is that I'm going to have maximum or minimums either at those endpoints or at 0 or negative 1. So the way that we check to see which one is my absolute maximum and which one is my absolute minimum is we just plug all of these in to see which one's highest and which one's lowest. So if I just start with the lowest number, we'll have f of negative 2 will be 2 times negative 2 cubed. Make sure you're plugging into the original whenever you do this, not the derivative. So we're plugging into the original because we need to know the y coordinate for this. So we got plus 3 times negative 2 squared that is going to be, let's see, that's -8 times 2 is -16. And that'll be 4, so that'll be plus 12. We'll get -4 for that one. I'm going to try f of 0. What is f of 0? It's just 0. It's okay if you do that in your head and just write f of 0 equals 0. Give us this free response. That's okay to do. I would not suggest it on these other ones unless you are really good at doing this in your head. But that one, you just see both of those are 0. You can write it. You don't have to write everything out. But you do need to write that down. Don't just think of it in your head and neglect writing it down. So we got f of, I should have done -1 before I did this one. You don't have to do them in order. I was just trying to, so my work was neat, but I failed at that. So this would be -2 plus 3, which would give us 1. It'll be a positive 1, right? I'm not missing it. This will be. You're going to do exponents first, which is going to square this and make it positive. So then you'll get the positive 1 times 3 there. Yeah, and make sure you do that because I know somebody else was running that problem. Maybe Luke. Yes, on that one that you had the big number, you had multiplied together first before you squared. But you'll square first. Yeah, on the test. Yeah, so it's a common issue. And then f of 1 is going to be 2 times 1 cubed plus 3 times 1, which is going to be 2 plus 3, which will give us 5. So if we look at the 4 answers that we just got, we got -4, we got 0, we got 1, and we got 5. And all we're doing is we're saying what's the highest and what's the lowest. So highest, that's our maximum. And lowest, that's our minimum. Now, for this one, it ends up being the endpoints and not the critical points we found in the middle. But you never know which one it's going to be, so you always have to test all of these. We would say for this that you have an absolute maximum of 5, which occurs at x equals 1, and we've got an absolute minimum of -4, which occurs at x equals -2. Now, if we looked at Desmos, we could find these really quickly from Desmos. It's pretty easy to see. But this is a way of doing this without having any graph at all. All right. So 7 says find the global extrema of f of x equals 2x minus 3x to the 2/3 on the interval from -1 to 3. So we need to do the same thing we just did on the last global extrema. Is the same thing as absolute, and it's asking for maximums or minimums. So we need to start off by finding that derivative. So because we got to get those critical numbers. So f prime of x, the derivative of 2x is 2. Here I've got to do 3 times 2/3, which is just going to give me 2. I have x to the, I got to do 2/3 minus 1, which will give me -1/3. Now, technically, you don't have to simplify this, but to me, it makes the next steps easier if you do simplify it. So you've got 2 minus 2 over the cube root of x here. And then I would get common denominators, because if you have common denominators, then you can just set your numerator equal to 0 and your denominator equal to 0. If you don't have that, then it makes it a little easier to look at the derivative. So it's a pretty simple fix here for common denominators. You just need to multiply by the square root of 3, or cube root of x on top and bottom here. And so that will give you 2 cube root of x minus 2 over the cube root of x. Questions on that derivative? All right, so we want to see where the numerator equals 0, because that'll mean our derivative equals 0, or where the denominator equals 0, because that'll mean that our derivative is undefined. So we'll do 2 cube root of x minus 2 equals 0, and we'll also just do the cube root of x equals 0. So right here we'll have 2 cube root of x equals 2. We'll divide off this 2 right here. We got the cube root of x equals 1. How do we get rid of a cube root? Cube it. So we will cube both sides, and x cubed, or 1 cubed is just 1. So x equals 1. Over here, we will just cube both sides. We will still get x equals 0. So 1 and 0 are our critical points that we have to test. Okay, here. So we need to test 1, 0, negative 1, and 3. So if I do f of negative 1, I'm going to rewrite this first. I'm going to do this 2x minus 3 times the cube root of x squared, just because it is a little easier for me to think of it that way. So I'll have 2 times negative 1 minus 3 times the cube root of negative 1 squared. And so that'll be negative 2. Negative 1 squared is 1. The cube root of 1 is 1. So this is negative 2 minus 3, which will give us negative 5. We'll do f of 0. It is okay on this one. Both of them have x's, to just go ahead and say it's 0. We'll do f of 1. 2 times 1 minus 3 times the cube root of 1 squared. That will give us 2 minus 1 squared is 1. Cube root of 1 is 1. So we just get 2 minus 3, which is negative 1. And f of 3, which is 2 times 3 minus 3 times the cube root of 3 squared. Now this one's kind of weird. We're going to have 6 minus 3 times the cube root of 9. Do we know the cube root of 9? We do not. So, and this is not calculator active. So what we're looking at here is we've got our 4 different numbers that we're looking at. We got a negative 5, we got a 0, we got a negative 1, and we got a 6 minus 3 times the cube root of 9. So negative 5, 0, 1, those are easy. We can compare those numbers easily. I've got to think about 6 minus 3 times the cube root of 9, because without a calculator, I don't know what that is. But I do know the cube root of 8. What is the cube root of 8? 2. And if I had 3 times 2, I'd end up with 6 minus 6, which is 0. Is cube root of 9 going to be bigger than 2 or smaller than 2? Bigger. A little bit bigger, right? So we're going to have 6. Oh, let me switch back to a pen. We're going to have here, I'm going to use some squiggly marks. We're going to have 6 minus, make sure, if you write this down, I would almost just think it, but since I need you guys to see my thinking, I'm writing it down. We've got 3 times something bigger than 2, like a 2.2, right? This is, if you were to write this, you would have to have squiggly marks because it is not equal. I would probably just be thinking this, but since I want you to see my thinking, I'm writing it down. That might not be that close, but I know it's bigger than 2, but it's not going to be all the way up to 3, right? Because 3, in fact, it's probably not even 2.2. It's probably more like 2.05 or something, but let's just say this. So I've got 6 minus 6.6, which would give me negative 0.6. Now, that's not exact, even close to exact, but is it good enough for me to be able to tell which one of these numbers is highest and which one is lowest? It is, because I know that this is going to be negative, so that means that 0 right here has to be my highest number. There's my maximum. All right. I also know that while this will be negative, it's not going to be lower than negative 5. Because, I mean, even if this was like the cube root, if this was the cube root of 27, right, which it is not even close to being cube root of 27. Cube root of 27 would be 3. 3 times 3 would be 9. 6 minus 9 would give me negative 3. Still higher than negative 5, right? So that negative 5 is my minimum. You will see these where they do this, where you don't know how to get that exact number. But it should always be something where you can use logic to figure out if it's the highest or the lowest number. And in this case, we know it is not the highest or the lowest number. Sometimes it might be the highest. Like if that had been 6 plus 3 cube root of 9, then it would have been the highest number because we knew it would be a positive number, which is bigger than 0. So you might get that sometimes where you can't tell exactly what it is, but you can tell if it's the highest or the lowest. So we would just make our conclusion on that we have an absolute minimum of negative 5, which occurs at x equals, what was that one at? Negative 1. And we have an absolute maximum of 0, which occurs at x equals 0. I would suggest writing it like this. Sometimes you don't really have to put that which occurs at. It's not asking for that. Sometimes you don't have to give the minimum or maximum value. You just have to tell where it occurs. But if you kind of are standard doing it this way, then you're going to cover what they're asking for, even if they didn't really need the other parts. Okay, questions? All right, gosh, I've got a lot more. Let's see. I don't think we need to do all these. Oh, trig. Trig. Okay, let's see. All right, let's do. We probably need to do one trig one. Let's do a trig one because that might throw you for a loop if we haven't seen it. So we got trig. Same thing, critical points. F prime of x here is going to be 2 cosine of x. We want to know where this would equal 0 or undefined. So if we have that, we could just divide both sides by 2. We are thinking about where cosine x equals 0. So on your unit circle, you're trying to think, where does cosine equal 0? Cosine is your x coordinate. So x coordinate is going to equal 0 right here. and right here, what's the values there at the pi over 2 and 3 pi over 2? So x equals pi over 2 and x equals 3 pi over 2. So those are your critical numbers. We need to test the endpoints and the critical numbers in the original, not in the derivative, but in the original. So we've got f of 0 would be 2 sine of 0 plus 1. What is sine of 0? 0, so 2 times 0 plus 1 is going to give us 1. We've got f of pi over 2. So we will get 2 sine of pi over 2 plus 1. What is sine of pi over 2? 1. So we got 2 times 1 plus 1. That's going to give us 3. We got to do f of 3 pi over 2. So 2 times sine of 3 pi over 2 plus 1. What is sine of 3 pi over 2? Negative 1. So 2 times negative 1 plus 1 is going to be negative 2 plus 1, which will give us negative 1. And we've got to do f of 2 pi, which 2 pi is going to be the same as 0 because they're in the same place on the unit circle. So you're going to get the same thing again there. You'll get 1. So we are looking at these 4 numbers and deciding what is our maximum, what is our minimum here. So for that 3 is going to be your maximum. The negative 1 will be your minimum. And you would make your conclusion, but for sake of time, I'm not going to do that because I'd like for you to do a couple problems before you go. All right, we are going to skip 9. We're going to look briefly at 10. Which of the following functions of x is guaranteed by the extreme value theorem to have an absolute maximum on the interval from 0 to 4? Extreme value theorem, whenever it was way back here, what were the conditions for extreme value theorem? It's got to be continuous, right? So when we look at this problem, what we're really looking at is, are these continuous on that interval from 0 to 4? So let's just start with the C and D because they are easier to do, right? For C and D, if that denominator equals 0, they're not continuous, right? So if we look at this, x squared plus x minus 20 cannot equal 0, so that would be factor at x and x plus 5 minus 4. So we'll get x equals negative 5 and x equals 4. So is that one continuous from 0 to 4 inclusive, including the endpoints? It would not be because of that 4. Negative 5 is not an issue, but that 4 is an issue. So C is a no. D, we got e to the x minus 1. If that equals 0, then this is undefined. So e to the x would equal 1. How do I solve that? Or I can just think about it. What x value would give me 1 right there? 0. So x equals 0. Or you could do natural log of both sides. Natural log of 1 is 0. Either way. So that one is undefined at 0. So that's the other endpoint. That one cannot be it. Alright. That leaves tangent and inverse tangent. And because I know very little about inverse tangent, I'm going to think about tangent first. What is tangent? What's the identity we could use for that? It's sine over cosine. And so that one is going to equal 0 or be undefined if cosine of x equals 0. And we just did that. Where does cosine x equal 0? Pi over 2 and 3 pi over 2. Now, is pi, let's just do pi over 2. Pi is 3.14159. We're going to divide it by 2. Is that between 0 and 4? It is. So you're going to have a vertical asymptote on tangent. So by process of elimination, B should be your answer for that. The inverse tangent looks like this. So whenever you flip that over the line, inverse tangent looks something like this, and it is continuous for all of those values. So if you knew that right away, you could choose it, but we know very little about inverse tangent, so I would probably go about it this way instead. All right, so let's look at this last one real quick. Let f be a function with selected values given. Which statement must be true? So by the intermediate value theorem, there's value c from 0 to 3 such that f of c equals 2. By the mean value theorem, there is value c such as from 0 to 3 such that f prime of c equals 2. And by the extreme value theorem, there is value c such that f of c is less than f of x for all x in the interval. What is the answer to this one? It's not D. It's not B. It's A. Why is it A? What is the condition for all of those? What do you have to have be true for all of those? They have to be continuous. Do you know that f is continuous? You do not know that f is continuous. So you can't make any of those conclusions because it does not tell you that f is continuous. Now, if they told you f was continuous, then you would need to kind of check and see whether or not those could possibly be true. But they do not tell you f is continuous anywhere in this problem. All you have are points here, so you don't know that it's continuous. It could be jumping all over the place. So that would not be the case. All right, so let me look through the book and make sure this is what I want. Let's see. It's kind of a lot. Let me make sure it's accurate and not excessive. All right. 7 through 10 are just graphs that you are just giving maximum minimums for. So you're just reading it from the graph like we did those first couple problems. All right. So 7 through 10 should not take long at all. 21 through 31 odd are like the problems that we were doing. To give you a hint on 31, think of the graph. Okay, because 31 we can't do algebraically. So think of what the graph is. If you need to, you can graph it on your calculator or Desmos. There. Let's see. 35 is a trig one. I do want you to do that. 41 is an E. 43. Yeah. Let's see what the 74, 76 is. I'll save 74 and 76, and we might do those as like a warm-up or something tomorrow to give you a little more reasonable amount to look at. So you got 5 minutes if you want to do one. Try to maybe start those graphs real quick. I know we don't have long, but you might could get those done pretty quick.